I would love to hear in your own words, sort of the definition of the topic. What is neuromorphic computing? Provide some of the basics, if you would.
Sure. Yeah. So from my perspective, neuromorphic computing is an effort to go back to the first principles of rethinking computer architecture from the perspective of what we understand today about the workings of the brain, really at the very lowest level. So focusing on neurons and the connections between neurons and the dynamics, the ways that neurons operate at a biological level. And understanding that and adapting that and applying it to the manufacturing, chip design technology we have available today. So as our engineering tool, seeing what lessons, what principles are applicable and try to rediscover a different way of performing computation, hopefully one that is achieving the energy efficiency, the latency, and the adaptability, the ability to learn, online, deployed in the real world with real world data, much better than what we can do today with conventional computer architecture.
And there are obviously a lot of touch points, as you and I've talked about in prior conversations, between the work you're doing and artificial intelligence and deep learning, more generally speaking. Talk a bit about that relationship, if you would.
Sure. Yeah. Well, from some perspective, everything is brain inspired in computing. If you go back decades, so 7 decades or more, to Alan Turing, von Neumann, Rosenblatt, some of the very original thinkers in computing and AI, they had the brain in mind. And so they were trying to emulate and capture the amazing intelligence capabilities in the one example we found in the natural world, which was the brain. So all of this has kind of a common family tree, so to speak. Quickly back in those days, there was a divergence between what is now called the von Neumann model, so our standard computer architecture that has advanced by factors of 1 million over the decades, and then meanwhile there's been another splinter, which is neural networks. So really taking this bottom up perspective of let's capture the more literal form that we find in the brain. So back in the 1950s, there was the perceptron, the first kind of hardware neural network. And that's the technology that over decades now has evolved into what we call standard neural networks or deep neural networks, deep learning. And just in the last decade is when we've had the computational horsepower and some of the data set availability to really make that particular approach, which has been decades in gestation, really successful and thriving and now changing the world, just in the last 10 years. But that really traces its roots back to that, 1950s, 1960s era modeling of neural networks, which is an extremely powerful model, but quite different from what we now understand as the way real neural networks, real brain networks operate. So what we're doing is we're taking a fresh look at really thinking about those primitive elements and seeing how they provide capabilities which are very different from what traditional neural networks do in terms of being deployable, operating at very low power levels, as opposed to technology which is much better suited for, say, data center oriented, very big memory sets, pre-collected data that is, kind of processed through it at once, training all the parameters in the network as you do in the sort of the deep learning paradigm, which is incredibly powerful when you have sufficient data and compute to perform those kind of operations, but is very, very different from the kind of learning and adaptation that we find happening in brains of real organisms.